So today we're going to be talking about school funding data using the tools that we created at EdBuild. EdBuild is a nonprofit advocacy group that researched education finance and modeled its impacts. But first, for some introductions, I'm Cecilia Detman. My background was in environmental policy. I did a lot of work in food systems, specifically mapping food insecurity, before I got a job at EdBuild, where I worked as a data analyst alongside Megan. And I worked more specifically on state reform and advocacy work, modeling student-based funding formulas for our state partners.
Hi, everybody. My name is Megan Brodzik. Before joining EdBuild's team, I was a high school math teacher for in a urban charter school in Milwaukee, Wisconsin, and then decided to switch gears and get into the policy and advocacy side of things, and was also a data analyst with EdBuild, working on the national reports and analyzing our national data sets, which we'll talk about today.
So first, I'm going to give you a background on EdBuild, who we were and what we did and why. Then Megan will do a deep dive into our school district data that we procured and processed for our national level research. We'll take a quick break for questions. And then in the second half of our talk, we'll discuss two of the toolkits that we built and published before EdBuild closed its doors last year. The first of which is our interactive user dashboard, which is kind of more of our semi-technical toolkit. And the second are two R packages that we built and published, EdBuilder and EdBuild Mapper. So like I said, EdBuild was a small nonprofit. We work to bring common sense and fairness to the way that states fund schools. That was like our mission that we all had ingrained in our minds. Through our research of school district borders, we wanted to show how America's school funding system is arbitrary in that it fails to support students in accordance with their needs. It's inequitable. It often produces higher funding systems in more affluent districts rather than the districts serving students with high needs. And it's segregating. It promotes division by incentivizing segregation along racial and economic lines. So in order to do this, we spent a lot of time poring over financial and demographic data and learning about its nuances, how it should be best used and understood by the public. And when EdBuild closed its doors in June of 2020, but since we had a planned closure, we were able to be thoughtful about the lessons that we learned and repurpose our data products for broader public use. And that's what we'll be sharing with you in the second half of our presentation. But first, to give you a little bit of context on our national level work and a sense of the types of questions we were asking, I'm going to briefly walk you through one of our products, Dividing Lines. Sarah Hodges was our director of data and visualization, and she created this map. It's an interactive map of every school district in the United States. There are a bunch of ways that you can play with it. You can toggle the year of data that you're looking at. You can toggle the level of school district that you're looking at, and you can toggle the variable that colors the map. So for example, you could look at the distribution of non-white students or median household income. I'm going to keep it on student poverty rates for now. So if you spend enough time staring at this map, certainly as much time as we did, you'll start to notice that some school districts are pretty messed up looking. I'm zooming into Jefferson County, Alabama right now. Jefferson County is home to Birmingham. And if you're not familiar with what Birmingham School District looks like, it is a quintessential example of gerrymandering. And if you dig into the reasons why it looks like this, you'll learn that Birmingham has 13 neighboring school districts because of this shape, 7 of whom were allowed to secede from the larger county district, despite being under desegregation orders and despite the fact that seceding increased segregation as well as the wealth gap between these now distinct school districts. And since 2000, there are over 100 school districts across the whole country that have attempted a secession from their municipal or county school district. Another thing you might notice is that there are all these island districts that are completely within other school districts. To illustrate this better, I'm going to zoom over to Piedmont. Piedmont is a tiny school district that's totally within Oakland. And Piedmont has found a way to get through. California has a tax revenue cap, and Piedmont is able to raise over $2,500 per pupil above and beyond that cap, which is problematic for a lot of reasons, but most obviously because Oakland, its surrounding school district, has a poverty rate that's 20 percentage points higher than Piedmont and a student body that is over 50 percentage points more non-white. So obviously a lot of data analysis and policy research went into exploring this and answering these kinds of questions, but it doesn't take very long to figure out that data points and borders that initially might look just abnormal and funky are actually quite patterned, and they're evidence of much deeper and more systemic issues in the way we fund our schools. So now Megan is going to show you how we created our national data set that underlies all of this work.
So EdBuild's master data set is national level data. It's an amalgamation of 6 different national data sets that I'll talk through in a minute. It is at the school district level, and the main focus is obviously school finance, but there actually are 4 iterations of the master data set in order to support various research questions that might differ from a school finance focus. They're available through school years 2012-2013, all the way up to 2018, which is the most recent year that all 6 of those data sets have data available. The bulk of the data set centers around school finance. So the Census annual survey for school system finances, otherwise known as F33. But EdBuild does some processing to this data set to fix some irregularities that we've found in the data throughout the years. So first we multiply by 1,000 just because the census gets rid of those zeros. But we also subtract some variables from total state and local revenues for each school district. The first is capital revenues. We exclude these from state revenues because they can contribute to large fluctuations in district revenues from year to year. We also exclude the sale of local property from local revenues for this same reason, those large fluctuations. And we also exclude charter pass-through dollars. So in about 2,000 school districts across the country, revenues received by the districts include funds that are passed through to charter schools that are not actually part of that district. And so enabled to avoid artificially inflating those districts' revenues, we subtract these pass-through dollars. And then we also do some state-specific processing. So in Arkansas, there's a variable called C24, which is mischaracterized as state revenue when it's actually local revenue. So we go ahead and subtract that from state and add it back to local. In Texas, recapture, which is the process of property wealthy districts sending some of their local tax revenue up to the state for redistribution, is characterized by the variable L12. And so in order to avoid any double counting in that redistribution, we subtract local revenues because they've already been included in the state share for those districts. And in Vermont, districts are currently undergoing a lot of consolidation. Some national data sets have caught up to this consolidations, F33 has not. And so in order to match up to our other national data sets, we aggregate enrollment and revenue variables up to the supervisory union level in order to match up, like I said. And then after all of that adjustment, we make a total revenue variable, which is total adjusted local revenue plus total adjusted state revenue. And per pupil revenues are found by dividing those adjusted revenues by fall enrollment memberships, which are also included in the F33 survey. So that's F33. And then these are the 5 other data sets we use. So the first is the Common Core of data. That's where we get our information on school district enrollment and racial composition. One thing to note for racial composition is that the Common Core has data on each individual race and ethnicity, but EdBuild created this variable called non-white students in order to research the systemic disadvantages faced by students and communities of color. We understand that this category is imperfect and puts white students at the center of the research, but it was the simplest way that we could find to look at systemic racism in education funding. Our next data set is SAPE, the Small Area Income and Poverty Estimates. This is where we get school age poverty rates, the number of students living in poverty. Our school district community indicators come from EDGE. We use median household income and median property value, as Cecilia showed in dividing lines briefly. And then we also cost adjust. Our cost adjusting index comes from the Council for Community and Economic Research. We do this in order to make national level comparisons, like in dividing lines. That is all cost adjusted so that you can look at the difference between a district in New York, say, and Georgia. And then finally, school district boundaries come directly from the census. Again, the composite school district boundary files. So once all of those data sets are joined together, we actually create 4 different master data sets based on various different exclusions. Our first exclusion is called the geography exclusion, the geography data set. We use this for projects about borders and mapping. This is the data set that we used in dividing lines. And that is all of the districts that have physical school district boundaries. Our next data set is the general data set. This is for projects with enrollment or demographic focus. It excludes districts that are vocational, special education, non-operating, or education service agencies, which are oftentimes how charters are characterized in the data. So exclude any districts with missing or 0 enrollments and any districts in the US territories. Our third data set is our finance data set for projects about education funding. This is the one that we use most often. It excludes everything that the general did, as well as any districts with 0 or missing operational schools, missing revenues, or any districts that have very high or very low revenues. We assume that if a district has more than $100,000 per pupil, that there's probably something wrong with that data. And our final exclusion is actually all. So this includes all of the districts. We use this only for exploration in order to look at a specific district that might not be available in any of the other data sets. And here's just a brief summary table to show you the difference between those exclusions. So you'll notice right away that all districts, there's about 18,000, but in each of our standard exclusions that we use more often, there's about 13,000. Looking at the student poverty rate, the average local revenue, the average total revenue per pupil, those numbers don't change dramatically at a national summary level, but when we're focused in on communities and neighborhoods, the exclusion that we choose matters a lot more. So now I think we'll open it up for our first question break, just to see if there are any questions about our data, what EdBuild was all about, anything like that before we get into our actual data tools. So someone asked, how much time and staffing did this take? EdBuild actually was a team of 8 people. We were open for 5 years. I think we were learning that entire time. So the master data sets and the tools that we're sharing with you today are kind of a culmination of everything that we learned throughout those 5 years.
And I would just add that I think the toolkits that we're going to talk through next, I don't know, Megan, would you agree? The last year of EdBuild, they were definitely a culmination of resources that spent a lot of time to put together, but we actually started publishing what we thought would be useful tools in the last 6 to 9 months of EdBuild's existence.
Yeah, and we've just got another question. As new years of data become available, how will these tools be updated since EdBuild has closed? We recognize that these tools will probably be useful beyond 2018 data year. So we have committed to having a member of our team update them, and we'll share the resources of where all these tools are available in the second half, but they will be updated continually. And yes, these slides will also be available as well, and we will email them out at the end of the presentation. Okay. So the bulk of the rest of the presentation is going to focus on our data dashboard and our 2 R tools, but I just wanted to quickly note that there are 2 other resources that can be helpful for both technical and non-technical users. So edbuild.org is where all of our national reports live, and that also has links to dividing lines, which Cecilia showed earlier, and a lot of the other tools that we'll be talking about. And then also, data.edbuild.org is our master methodology page, which goes through all of the methodology that I briefly touched over in the last few minutes. So if you had more in-depth questions about the data, you can go there. And then also through that website, you're able to download all of our master data files and all of our master shape files. And so you don't need to be an R user at all in order to get access to those files.
So for the next, 10 to 15 minutes, I will be walking through EdBuild's school district data dashboard. The impetus for this project was to provide a way for people to conduct their own robust and detailed analysis without having to open a statistical or mapping software. We chose R-Shiny as the platform for the dashboard. If you're not familiar with it, R-Shiny is an R package. It allows you to use code in a web browser and embed pretty complicated but nice looking visuals that are also easy to use and customizable. I'm not going to talk about how we developed the app. We're going to be focusing on the user experience and how we intended for the dashboard to be used. But if you do have questions about the backend, I am happy to answer them. So the first thing we're going to do is a general exploration of a geography. There are a lot of elements in the dashboard, and I would like to highlight some of the more interesting features that you can use to learn how school districts are distributed generally in a state or a region that is important to you. The next thing we'll do is more of a case study and use the dashboard to answer a research question: which school districts rely heavily on state revenue in the face of COVID-related budget? This topic is obviously critically important right now. We know that schools are facing an enormous budget shortfall now and into the foreseeable future. From a funding perspective, it's important context to remember that local revenue comes from property taxes, which is a big issue in and of itself. It's a primary driver of inequity on the ground. But property taxes are actually a fairly stable form of revenue as opposed to sales tax and income tax, which is how states fund schools. In the times that we're living in, where we expect large drops in sales and income tax revenues, schools that rely on funding from the state are considerably more vulnerable. So the best way to do this is live. So this is the data dashboard. When you open it up, this pop-up tells you a couple important things. First and foremost, that the school districts in the dashboard are school districts with geography. What this means is that not every student and not every school is represented here. As Megan just talked about, we had exclusions in our national data sets for a reason. And so we had to make a decision about which one to use in this app. And as you'll see in a few minutes, there is a map in the dashboard. So we chose the geography exclusion. There's also data available from 2016 to 2018. And there is a link here to data.edbuild.org, which Megan also just talked about. So the first thing you see on the homepage is that we are in the geography. We're looking at a national view. This plot is looking at total revenue per pupil across student age poverty. And these are states. So every dot here represents a state. This is New York. Just at a high level, you can see that the overall system is regressive. As poverty increases, total revenue per pupil decreases. This is the first thing you see for a reason. We want to encourage people to be thinking about equity when they're looking at finance data. But a couple of important caveats. This is not cost adjusted. Cost adjusted revenue is something you can turn on and off in the toggle in the sidebar. Another thing that I think it's worth saying explicitly is that EdBuild worked to create national data sets because we were comparing across states, and sometimes we were comparing school districts within a state. But for those of you who work closely with state agencies, you probably know very well that states report different data than what's available in national sources like F33 and NCES, particularly for revenues and enrollment. So if you're seeing slightly different numbers at the state level, that's not a bad thing. Usually it's because the data actually does mean something a little bit differently, and it should be used a little bit differently. I'm going to use all the features here, especially the ones that I think are very interesting, to dig into what school districts look like in a state. And I'm going to use Minnesota as an example. So now every dot in the scatter plot is a school district in Minnesota. And you can expand and contract all of the sidebar elements to do more things with the data. This feature, I think, is very cool. It allows you to add and subtract school districts from your analysis. So this is a list of all of the districts in the state, and you can gradually add them just to compare certain areas. Another thing you can do is change the X and Y axis variables. Right now, we're looking at total revenue per pupil. You can see a trend-ish, but there's a lot of noise. I'm particularly interested in all of the points that are kind of above the median revenue and what's going on there. So I'm going to change the total revenue to just state revenue. And we can see that these districts that were receiving a lot of revenue disappeared. So we can probably attribute their revenue to local taxes, but we still have this outlier here, Net Lake Public School District. It has a very small student body of 57 people, and it's receiving significantly more revenue from the state than other districts. There are a few ways that you could start to investigate what's going on here. This option here on the sidebar to specify a data range allows you to filter on any variable that's in the data set. We could obviously filter on state revenue per pupil and remove that outlier and make a nicer looking plot. But I want to test my enrollment theory and filter on pupils per square mile. The minimum and the maximum values are here. So what this means is the most dense school district in Minnesota has 916 pupils per square mile. And I'm going to change the minimum one. So everything adjusted. Net Lake School District was way up here. It was removed from the plot along with 10 other school districts. So these are all districts that have less than 1 pupil per square mile, which is incredibly rural. And I think rurality is way more interesting to look at on a map. So our default for maps is obviously student age poverty, but I'm going to change that to pupils per square mile. See the top portion of Minnesota is very rural, with the exception of some metro areas and the Twin Cities region. And I believe this is Interstate 94 that crosses right through the state along that track. I'm going to do a couple other things just to round out our analysis a little bit. I'm customizing the table right now, adding what I think are relevant variables. And I'm going to search for that school district that we were wondering about. And if you highlight the table, it also highlights the map. So Net Lake is in a very rural area. The census declares it a rural remote school district. There's 1 student per square mile, high poverty, low median household income, and the state is doing a lot of work to make up for its lack of local revenue generation. So that's just an example. That didn't take very long to learn a lot about the way school districts are distributed on the ground in a state that I don't know very much about. And then we will jump into our research question, which is which states and school districts rely more heavily on state funding. So we're going to start on the revenue sourcing tab. This tab is really only good for one thing. Looking at this graph, it's not very interactive or exciting, but this is just showing you where states fall and how they source their revenue. So Hawaii, for example, is 1 school district. Almost all of its funding comes from the state. Vermont, similarly, 85% of its revenue comes from the state, whereas Vermont's neighbor in New Hampshire sources 70% of its revenue locally. And nationally, it's a 50-50 split. To dig into our question a little bit within a state, I'm going to use Ohio as an example, and I'm going to change the y-axis to % state revenue. So you can see right away the relationship between poverty and revenue. As poverty increases, the proportion of funding that comes from the state also increases, at least for these school districts. This is normally a sign of a very healthy funding formula. However, in the current moment, what it means is that these very, very high poverty districts are a lot more vulnerable. And the other thing that is important about this, the dot size correlates to enrollment. This is representative of a lot of students. And if you wanted to see how this plays out in your community, you could filter your data set a little bit. So I'm going to pretend that I'm from Cleveland. So Cuyahoga County is actually huge. It has 31 school districts. So I'm not going to highlight them all. But if you start to click here, you can see the plot points bolded. This one over here is Cleveland, obviously, but right away you can tell there's a huge range in how school districts are going to feel these budget cuts. And then we're going to look at this on a map and change the map to % state revenue. So if you know where Cleveland is, you've already seen it. Cleveland, and actually East Cleveland is a tiny school district that's also kind of clustered here. It's really isolated compared to its mostly wealthier, whiter suburban neighbors. And just to illustrate what we already know, these same neighboring suburban school districts can and do generate a lot more local revenue. And so they won't feel the impacts of COVID budget cuts quite so sharply. I think in an ideal world, when we're armed with this kind of data and information, we can use it to inform policy and decision-making that happens at the top. Stimulus money is going to be distributed to states and school districts. And with this data, we know that funding should definitely not be distributed equally. It should be distributed proportionately, definitely in terms of enrollment, probably poverty, and also expected local revenue contribution. So knowing how this plays out in your community and what factors are driving economic inequality, you can better advocate for the best way to move forward in your area. And then I'll show you one other thing. You can export some of this stuff. You can download an SVG, it's just a picture of this plot. You can also do a lot of table customization. You can add fields and you can download the table, and that's how you would download the plot. And these, I'm sure that many of you are involved in local politics and advocacy work on the ground, and these can be very compelling reporting tools you can share with your legislators and community partners. So there's a lot more you can do in the dashboard, but we will provide a link so you can play with it at the end of our talk.
So we also built a technical toolkit in R for our users to dig into this data. The packages are called EdBuild R and EdBuild Mapper. They are both on CRAN. And when we share this presentation link, that About the Packages link goes through a lot of vignettes and examples of how to use the packages. I'll go through some of those examples today, but for more information, definitely check out that link if you're interested after the presentation. So our first package, EdBuild R, like I said, it's on CRAN, so you can load it into R. Throughout these slides, if there's any white square with text in it, that's R code, just to show the examples of what's going on below. There are importing functions, analysis functions, and functions to make formatted tables within this package. The package can import our master data set, obviously, both by individual year and longitudinally. You also can import our codebook. But if you're just interested in the school finance side of things, you can pull in the F33 finance data separately, both processed and raw. Our analysis functions, the first is called Big Borders. That pools local revenue for school districts at either the county or the state level to see the effects that has on individual districts. NADIF function calculates the difference and national rank for a selected variable between all school district neighbors. SDNeighbor creates a data frame of any school district and their neighbors with user selected variables. And the two formatting functions, SDNeighbor XLSX creates a formatted Excel table of any school district and their neighbors, while SDTable creates a formatted Excel of all school districts in a given state or a given county. So master poll, that's really the bulk of our package. So here we're just using the master poll function to explore those different exclusions that I talked about earlier. You'll see in the function, you have the option to specify your data year. This example uses 2017, and the data type. So we have our finance exclusion here, but you can put in the geography, the general, and the all districts as well. Using just the scales function to make this table a little prettier, you'll see here that we've got our summary table of all of our different exclusions, which I showed you a few slides back. And so this is an example of how to get those national summary statistics right from our package. Our next function is NADIF. This function allows you to find the difference, like I said, between pairs of school district neighbors and to calculate them based on rank from largest to smallest. Let's say I'm interested in finding the school district borders that have the largest difference in percent non-white enrollment. Say NADIF, data year is 2017. And I know that I want to look at percent non-white, but I'm not exactly sure what that variable is called in my data set. So I put diff var equals options. And that will give you a list of all of the variables that this function can rank on. Throughout our package, this options feature is included in a lot of the functions to help users in the case of picking variables when you might not know the spelling or the name exactly. Once I find in this list percent non-white, so I think that's number 11, percentage point difference in percent non-white enrollment, I can go ahead and use my NADIF function. I'm making a table here of neighbors. I've specified my data year, 2017 again. My diff var, now I've got the exact spelling and the exact name of that. Type equals like. As we've kind of alluded to, school districts are divided often by grade level. So there are unified districts, elementary and secondary districts. By specifying type equals like here, you are saying that you only want to analyze districts of the same grade level. So unified to unified, elementary to elementary. You most often would want to do this because comparing secondary and elementary districts sometimes doesn't make sense. Oftentimes there are logical reasons why funding would differ between those two types of districts. So it's good to compare like districts. So I'm selecting some variables that are of interest and just looking at what I've got here. just looking at the head of this table, I can see that these enrollments look really small. The gaps in percentage point non-white are very large, but my enrollments are oftentimes under 50 students. And so in order to make sure that that proportion of non-white students is as accurate as possible, I'm going to filter this table based on enrollment. So here I have decided to look at just the top 10 neighbors with enrollment more than 1,000 students. I've filtered for enrollment greater than 1,000, taken the top 10 and done some formatting. And now I've got a table of districts that I recognize a little bit more. So the first is Birmingham and Mountain Brook is the number 7th neighbor pair with the largest gap in percent non-white enrollment. Birmingham City Schools has 99% non-white students, while Mountain Brook only has 4%. And as I go through this list, I actually see that Alabama shows up twice. They're also number 28 with neighbor Walker County, and they have an 89-point gap. So I want to dig into Birmingham a little bit more and see what's going on with the rest of its neighbors. And I can do that using the function SDNeighborXLSX to create a formatted table of any given school district neighbor. So again, I want to focus on Birmingham. So I've got the unique ID in there for the school district, which you can find in the master poll function in our master data set. I've said table vars equals options to look at which variables I am allowed to put in my table, and it will pop up with a list of those. So then once I've selected name, enrollment, poverty rate, percent non-white, etc., I've decided to make my table for 2017. A note will pop up in R telling you how to save this table. And so once I do that, and if I open my Excel, you will have a table that looks something like this. Birmingham is the first district you see with those variables you've selected, and all of its neighbors are listed down below. And so looking at this table, you can see that Birmingham is not only generally more non-white than the rest of its neighbors, but it also has a higher poverty rate than all of its neighbors. So you can use this function to look at any variable that you'd like and really dig into specific neighborhoods. And then our second R function is EdBuild mapper, which is the spatial function pairs with EdBuild R. So again, we have importing functions, analysis functions, and functions to create formatted maps. For importing, you can import either the state shapefiles or the school district shapefiles. Our analysis function here is called borders. That creates a data frame or line string object of the borders between neighboring districts. And our formatted maps, you can either make a map of all of the school districts in any state or county with SDMap, symbolized by a selected variable from the EdBuild master dataset, or SDNeighborMap, you can create a map of any school district and all of its neighbors. So using ShapePoll, that imports our school district shapefiles. So again, you specify which data year you're interested in, 2013 through 2018. And you have the option here of with data equals true or false. If you say true, that will attach our master data set to the shapefile so that you don't need to load in both packages and do the joining yourself. A note will also pop up that tells you that we've simplified this shapefile. That's just to make the analysis in R quicker and to create the maps faster. But if you are going to use any of these maps for final visualizations, the unsimplified shapefiles you can download directly from NCES. Here's an example of how to use SDMap. We've decided here to map Connecticut with the variable student poverty. Again, that note pops up that says, FYI, this is a simplified shapefile. And a note will also pop up telling you how to save the map in case you would like to take this outside of R. Here we've got a map of Connecticut symbolized by student poverty. It looks a little bit like our dividing line map, but you've created it yourself. Obviously, this is static, so you can't hover over it. But it's a quick way for you to do very little coding and come up with a pretty nice looking map. We also have SDNeighborMap. So that creates a map of any school district with all of its neighbors symbolized by a selected variable. So I'm going back to picking on Birmingham again. I've got SDNeighborMap, the unique ID, and the map variable percent non-white. And so you'll see the map here. Birmingham is the one outlined in black, showing how crazy its borders really are. And I've just pulled in the table that we made earlier so you can compare side by side how you might use these two packages together. We also have the function called borders. This function is a little bit different than the others. It doesn't necessarily rely on our master data set, but this function creates a data frame or a line string object of the borders between any neighboring polygon shapefiles. So we've optimized it to find the border between school districts, but any polygon shapefile can be used. Instead of putting here shapefile equals 2017, you can actually put in the path to your own shapefile. As long as it has a unique ID, it will be able to process that shapefile and find the line string border between the shapes. It does take about 15 minutes to run, just as an FYI, but it is really useful. This is something that we found difficult to make in some of our national reports. And so we decided to build a function for people to find the borders between any shapes that they would like. If you want to see a full vignette of how this function works in action a little bit more, you can go to that About the Packages link that I mentioned earlier, and there's a more in-depth example of this function. So like I said, these packages are on CRAN, so you can install them directly from there. You also can install them from EdBuild's GitHub. I also wanted to draw attention to one other repo that EdBuild has available, which is all of our scripts for all of our national reports. So you can go there and view all of the scripts we used. Oftentimes we use EdBuild-R and EdBuild-Mapper to do those reports, so you can see them more in action and recreate any of our national reports if you are so inclined. So just as a recap, these are all of the data tools and resources that EdBuild has opened up. Dividing lines, the interactive map that Cecilia started the presentation with, data.edbuild.org, our master methodology page where you can download the data sets directly, the school district finance data dashboard, which Cecilia walked through to visualize finance enrollment and demographic data, and our two R packages. So we have a question, how detailed is the data at the school district level? For New York City, for example, city is one big school district in the data sets you have, or can you see the 32 local New York City school districts? So in our data set, New York City is counted as one school district. Generally, the data sets are not very specific. They don't go into school level data or anything like that.
We use NCES's school district level data sets and process those, but they do provide school level data sets if you're interested in exploring them. And they contain much of the same information. So for the most part, they could actually be processed in a really similar way.
We have another question. If you toggle cost adjusted view per pupil spending, does that show the surplus amount per student?
No, it just switches the revenue that we're using from the one that is reported to the state to the one that we have cost adjusted using the index.
And then a follow-up question, are there any success stories of using this data to redirect spending? So I think that would go into our state engagement work.
Well, I think it goes into all of our work in different ways. A lot of our national reports shed light on issues, things that were happening on the ground that were a little bit more invisible or too wonky for people to really recognize. The secessions that we talked about, that we used Jefferson County, Alabama as an example, we published reports on secessions and kind of brought them to the forefront because that's a phenomenon where small communities choose to redraw their borders around their community and break away from a larger district and pull their funding away at the same time. That is something that is happening and increasing. And so I believe that there's an example of a couple school districts that our report made local news in their area, and people were able to prevent that secession from happening. And if you're interested in reading more about that, we have links to those reports on our website. For the state level funding formula reform, we did a lot of work working closely with states and legislators to come up with reform policies, ways that they could make their funding formulas more equitable. And we used a lot of these visualizations, the scatter plots that looked at poverty metrics against revenue to kind of identify places that they should be weighting more heavily in their formula and distributing money in a different way. That's definitely a very general overview of kind of how we did that kind of work. But we worked in a total of, I think, 8 states on their funding formula over the course of